Welcome to Part 3 of Intermediate SQL. We will master group by and having with real string functions to business KPIs. Learn optimization tips and ace and level up your data skills.
Candidates often fail data engineering interviews at companies like Airbnb because they struggle to map messy, raw datasets back to core marketplace dynamics. To create a reliable host quality KPI, you have to start with this: a raw bookings table containing inconsistent timestamps, missing fields, and unformatted text. Before writing logic, you must isolate 3 prerequisite inputs: the check-in date, the host name, and the cancellation reason. Starting with these specific columns ensures you build your metrics on the actual business event, the booking, rather than just running code on whatever data is easiest to query. First, we sanitize the inputs. We apply cast to standardize the string-based dates and wrap host names in upper and trim functions to eliminate trailing spaces and casing discrepancies. Watch out for the date sorting trap. If you format your dates as strings like Jan 2024, the database will sort them alphabetically, placing April before January. To prevent this, use date trunc to round timestamps to the month. This maintains the chronological order by keeping the data as a date object instead of a string. Next, we address the null values in the cancellation column. Since a missing value indicates the stay wasn't canceled, we use COALESCE to replace those nulls with a completed status. This is a graphic showing quality enforcement. Applying these row-level sanitation steps in your code is what prevents corrupted records from skewing downstream business reports. Once the data is clean, we need to find the total bookings per host. To ensure the final metric is statistically significant, we only want to include hosts who have at least 50 total bookings. This is the SQL execution order. The where clause executes before the data is grouped, which means you cannot use it to filter an aggregated column that hasn't been calculated yet. To filter based on booking volume, we use the having clause. Because having runs after the grouping step, it can correctly isolate our high-volume hosts. To separate completed stays from cancellations, we use conditional aggregation. We place a case when statement inside a sum function, assigning a 1 if the status is completed and a 0 otherwise. This pattern allows the database to scan the rows vertically and pivot that data into separate, horizontal columns for each host in a single pass. This is a diagram representing streaming deduplication. Using this logic to filter and aggregate ensures that you are extracting unique, valid events from a high-volume stream of noisy data. Finally, we combine these elements to calculate the host quality score by dividing the sum of completed bookings by the total booking count. This integrated architecture uses cast and coalesce for cleaning, groups the records, and then applies having and conditional sums to generate the final metric. This promoting to silver icon represents the state of the data. Writing logic that handles cleaning and aggregation in one step mirrors the structure of production-ready pipelines, where data must be validated before reaching the final layer. This cheat sheet provides the full syntax for the window functions and aggregations we've used. Master this sequence: clean, group, aggregate, and filter to handle any data modeling question on a whiteboard.
Start thinking like data professionals. Subscribe to Data Hacks Daily by RS for the next part. Keep learning. See you in the next video.